Okay, so this is going to be the last lesson of Unit 4, and it should remind us of our lesson on solving rational equations. They're both similar in one way. So when you solve a rational equation, and I'll just remind us of what those looked like, we had equations that looked like this, like 1 over x plus 2 equals 5 over x. Right, and we would go about solving this. We would multiply both sides here by x plus 2 times x. And we'd do the same thing over here. And then we'd have some cancellations. And then we'd solve x equals 5x plus 10. And we would go about finishing this, right? And when we're done, we would end up with something that would be a number that we would have to check and make sure that it actually is a legitimate solution, because we have these things called extraneous solutions. So before we start doing these, I want to make sure that we remember what would constitute or what would count as an extraneous solution. All right? So let me get this out of the way here, and let's just remind ourselves of what those extraneous solutions can be. So if we finish solving and we get a number, and then we test that number in the original equation, but it turns out that by testing that number we get something that's undefined, like a number over 0, or we get something that's imaginary, like the square root of a negative anything, then we're not going to count these as solutions. They're extraneous solutions. We also could encounter a situation where it just creates an unequal statement. We may get a solution that's totally legitimate and end up plugging it back in and get something like this, right, which is not true. So if you plug it back in and you get something that's totally untrue, then it must not have been a solution in the first place. All right, so when we solve these, we're going to run into some of these situations, but in solving the equations, we're not going to be doing anything crazy. It's just like what we've always been doing when solving equations. We just have to remember here that if there is a radical involved, we have to check for extraneous solutions, just like we did when we had rational equations. All right, so if we take a look at this first problem, A is pretty quick. In order to get the 3x out from under the radical, I just have to square both sides or raise both sides to the 1 or to the second power, because this is really 3x to the 1/2. So in doing that, this is going to cancel. I'm going to have 3x equals now 36, and I'm going to divide both sides by 3, x equals 12. And now I just have to check this and be sure that 12 is actually a solution. So the square root of 3, and instead of x, I'm going to use 12, has to equal 6. And when we do this, a lot of the time, we would say that when we take the square root of a number, we could get positive solutions and we could get negative solutions. We would say that sometimes. All right? This radical that is written here is just going to account for the positive solutions. There may be cases in the future where you're taking other math classes where you might see this written as plus or minus the square root or the fourth root or third root or whatever. But in this case, all that says is the square root. So this is implying right now, because it's already written, I didn't create this square root, it's already there. It's implying that I want only the positive solution. So 6 is the square root of 36, and 6 equals 6, so we're fine. 12 must be our solution there. All right, let's go ahead and do another one here. Example B is the fourth root of 2x plus 1, and again, in order to get rid of that fourth root, I just have to raise both sides to the fourth power, and that's going to cancel the root on the left side of the equation. Now I have 2x plus 1 equals whatever 3 to the fourth is, and it turns out 3 to the fourth is 81. And I'm just going to continue to solve. If I subtract 1 from both sides, I get 80, and divide by 2, I get 40. Okay, let's check it and be sure that we don't run into any issues. So I have to make sure that the fourth root of twice 40 plus 1 is actually 3. 2 times 40 is 80. 80 plus 1 is 81. You could use any calculator online or graphing calculator to check this, but it is true that the number, that if you multiply it by itself 4 times, to get 81 would be 3. So this is true. 3 equals 3. All right, so we're going to keep our solution. Turns out x equals 40 is our solution. I'm going to do one more with you, and then I'm going to have you do D before you come in on your own tomorrow. Okay. So C starts to take this to another level. Again, right now, to get rid of that radical, I can square both sides. And this is a tip here that I want to make sure that we follow moving forward. There's a difference between the way C and D are laid out. C already has the square root on its own side, but in D, we have the square root and we have this minus 2 here as well. My tip is always for you to isolate the radical first and then get rid of it. So make sure that your first step is to isolate the radical. I say a radical because we may run into some equations where there are multiple square roots or cube roots in the same equation. So we'll see some of those later on. But anyway, in example C, we already have that radical by itself, so I'm going to raise both sides to the second power, and be very careful that you raise the entire right side of the equation to the second power as well. Because when you do that, now you do have 8 minus x alone on this side, but on this side you have 2x minus 1 squared. So you're going to have to expand that. Remember, you cannot distribute this exponent across subtraction or addition. So you have to expand this. We have to FOIL this. All right, so we'll end up with 8 minus x equals 4x squared minus 4x plus 1. Since this is a quadratic, I want it to equal 0 so that I can finally solve it. So I'm going to take each of these two terms and move them to this side. I'm going to have to subtract 8. That's going to leave me with a minus 7. And I'm going to have to add x. And that's going to leave me with a negative 3x. So 0 equals 4x squared minus 3x minus 7. Okay, and if I want the solutions to this, then I need to factor it somehow. I'm going to use the grouping method and find a list of factors of negative 28 that add up to negative 3. And the ones I'm going to choose are negative 7 and 4. All right, so I'm going to skip ahead a couple steps here and get to my final factors. All right, I did a couple steps of the grouping method here, and I now end up with 0 equals 4x minus 7 times x plus 1. And some of you might just be double bubbling and using guess and check to figure out what those factors should be, and that's fine too. All right, so if these are my factors, then individually I'm going to set them each equal to 0 and then figure out what my solutions must be. So one of my solutions is going to be negative 1. That comes from x plus 1 as a factor. And then my other solution is going to be 7/4. So I have two solutions, maybe, but I do need to remember to check both of these solutions. So over here I'm going to do my work and check them. All right, so first let's go ahead and check that 7/4 because it looks nasty, but it's really not going to be as bad as it looks. Okay, so I have the square root of 8 minus 7/4 equals 2 times 7/4 minus 1. All right, I'm going to need a common denominator under this radical, which is going to be 4. So this is going to become 32 minus 7 over 4 equals, and over here I can rewrite this as 14/4 minus, and I guess I'll just call this 4/4 just to make it easy. Okay. So now I can simplify the left side of my equation here. I have the square root of 25/4, which is a pretty nice number because both 25 and 4 are perfect squares. And over here I have 10/4. So the left-hand side becomes the square root of 5, or 25, which is 5, and the square root of 4, which is 2. And the right side reduces also to 5/2. So that actually works. 7/4 is a solution. You may have thought that because that's a fraction that we're going to end up throwing that one out, but that's not the case. That one actually checks out here. Let's check negative 1. Just use this space over here. I have the square root of 8 minus negative 1 equals 2 times negative 1 minus 1. 8 minus negative 1 is 9. And over here I have negative 2 minus 1, which is going to give me negative 3 on the right-hand side. And this is what we talked about earlier. This is not the plus or minus. This is not the positive or negative root. The root was there before the equation started. So it's implied that that is the positive version of the root. If they wanted you to consider both, the equation would have begun with a plus minus right there. But they don't want you to consider both. Anytime you introduce a radical into an equation, you have to consider both. All right, but that was there before we started this equation. So the square root of 9, not the negative square root of 9, is 3. And 3 is not equal to negative 3, so that's a problem. What that means is we have to throw out negative 1. That's going to be an extraneous solution. And so our only solution is x equals 7/4. All right, so I'd like you to do D on your own before you come in tomorrow, and then we'll check our work and we'll practice for the duration of the period. But for the most part, you're just getting rid of radicals by using the appropriate exponent, and make sure that you're checking for extraneous solutions. Okay? See you guys tomorrow.